Good afternoon. Today is Professor Dr. Nasima's birthday and happens to be a day of convocation also. And there's a 4 o'clock lecture, independent lecture about Deshpande. And today, our student, Dr. Chetan Kozal, got a Totem Family Medal for the best thesis. So,
Hello everyone. I am Mayur Gatske. I am second year PhD student in CAOS. Today I am presenting the paper by Prakash Amol. The title of the paper is Impact of Rossby Waves on Chlorophyll Variability in the Southeastern Arabian Sea. The seasonal winds along the western boundary of Bay of Bengal generate Kelvin waves which travel along the east coast of India, uh, turning around the Sri Lanka and radiate offshore as Rossby waves of the southwest coast of India. So these Rossby waves can account for 5 to 20% of variation in chlorophyll concentration in the world. During winter monsoon, a downwelling Rossby waves is observed in the sea level data accompanied by the poleward West Indian coastal current. While in the summer monsoon, the Rossby wave is downwelling and the WSEC flows equatorward. The high and low near the Lakshadweep Islands locations are observed because of the Rossby waves and these Rossby waves propagate westwards with the speed of approximately 16 to 80 centimeters. So the monsoon currents in southeastern Arabian Sea are driven by geostrophic flow associated with these radiated Rossby waves. The data they used are the altimeter data uh, from Global Ocean Grid. They have taken the sea surface height and the sea level anomaly was calculated relative to the mean surface height from 1993 to 2012. The data, the resolution, spatial resolution of the data was 0.25 and they took the everyday data. The second data they used is chlorophyll A climatology. It is monthly climatology generated from the WIFS. So data is gridded at 0.25 degree resolution. Third data used is Oscar for ocean surface currents. And the resolution of the data is 0.33 degrees and it is presented at every 5 days. So I'll be discussing results. These are two. The first image represent the SLA and chlorophyll concentration during the winter monsoon, and the second figure presents the SLA and chlorophyll concentration during summer monsoon. So first two panels are of SLA, then followed by two panels of chlorophyll for November, December. Then again for January, February SLA, January, February for chlorophyll concentration. Same goes with the period of summer monsoon, and the period is from May to August. So one thing to notice here is most of the chlorophyll concentration is along the coastal region, like near the coast of India, Sri Lanka, and Lakshadweep Islands. Uh, the, se- second, uh, the second observation is where there is high in the sea level anomaly, we will find the like high concentration of chlorophyll near to the uh, highest peak in uh, SLS, and it is also observed that the concentration amplify towards south of this highest peak in SLA, where the summer monsoon current is strongest. We can see here the the highest peak is near the southeastern boundary of India, and the concentration amplifies near Lakshadweep Island, and where the summer monsoon current is strongest. And from these figures, we can see that uh, initially the concentration is near the coast. Then, as these SLAs move westwards, as we can say that the Rossby wave propagate westwards, this concentration also propagate westward. But in contrast with this winter scenario, in the summer monsoon, there is no propagation of the chlorophyll in the westward direction. Most of the chlorophyll is concentrated near the boundaries of the uh, coasts. Okay. So the chlorophyll spreads offshore from June to August and begin retreat by September. This is also one of the observations. And unlike in the winter monsoon, the offshore spread of chlorophyll is uniform. As we can see that in this figure, second figure, the offshore spread is uniform as compared to this scenario in the winter monsoon. This figure shows the longitude time diagram for east-west propagation of chlorophyll with the baroclinic Rossby wave at 6 degree north. Okay. So it can be observed that the chlorophyll high extends till 70 degree east uh, here up to this line are mostly in the winters from January to sorry from November to February. Okay. The chlorophyll high often leads the sorry this the chlorophyll high often lead the highest sea level crest by 1 to 3 months. So these are the sea level crest and these are the chlorophyll highs. So chlorophyll highs are always leading to the sea level crest by 1 to 3 months. The westward propagation speed of the chlorophyll that is 21 to 32 centimeter per second roughly matches with the second baroclinic speed of Rossby wave. Discussion. Westward drift of the chlorophyll with the wave propagation being more prominent during winter than the summer. Then the author proposed four mechanisms to study the influence of Rossby waves on surface chlorophyll concentration. First is eddy pumping, which brings the nutrients to surface. Then second is uplifting the surface chlorophyll maximum to surface layer. The third is accumulation of phytoplankton detritus at convergence zones. The fourth is horizontal north-south advection of chlorophyll concentrations. Uh, the geostropic currents induced by Rossby waves could also influence the horizontal transport of the chlorophyll and is evident during winter monsoon. Uh, Summary. The observed evidence for westward propagation of planetary wave-like feature in sea surface chlorophyll concentration is observed in SEAS. During the winter monsoon, that is from November to February, the high concentration of chlorophyll along the west coast of India and Sri Lanka drift westward along the downwelling Rossby waves, roughly with the second baroclinic speed of the wave. Then the Oscar suggested that the chlorophyll concentration, the surface chlorophyll concentration is affected by the geostropic currents also. Then the westward migration of chlorophyll is weak in summer monsoon and strongest in winter monsoon.
So you mentioned four mechanisms.
Yeah.
Which is working? All the four?
Here.
Together, which is the dominant mechanism?
Here, the first one is dominating. Yeah. Like they have given a short, like brief description, but they have said that the first mechanism is dominant here.
But I'm very explained how eddy pumping works here.
No. They have explained about this thing more,
Okay.
and I didn't get what they're saying. That's why I didn't put it in the slide. The first one is due to the due to the AD pumping only, but second one can be because of the uh, convergence or divergence of the waves. Mostly here the Rossby waves are downwelling, so they will be pumping the water uh, upwards. That's why this it also forms the AD like structure. But this uplifting surface chlorophyll, I don't know much, but there might be microprocess also, like double diffusion and all. I don't have a clear idea about that. No, 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 no.
Okay, thank you.
Thank you.
Yeah, I'll give my talk also short so that we finish before 3:45. So the last 1 week, monsoon has been going as per what the prediction was made last week. So as of yesterday, it was 442, 443 millimeters cumulative rainfall, and today it will be 450. So we already crossed 450. We have another what? Today is 28, 29, 30, 34 more days. So I think we'll come close to 480, which I had predicted last week. It will happen. The only interesting issue, if you look at the forecast, so this is the comparison between forecast starting 16 July to yesterday and the observation. You can see that there are errors. On some days, the observation, which is blue dot, is much more than forecast, 1, 2, 3, 4 days. And there are also days when the forecast was too high. So that's why I like to look at weekly mean. Weekly mean things get averaged out. So all I can say is, as of today's level of accuracy in models, we can only be confident about weekly mean all India rainfall. That's all we can be confident about. Anything smaller in time or in space, you're in trouble. Okay, but that's not a bad thing forward. The next 10 days, again, according to this model and other models, the all India rainfall will be close to climatology. Okay. Now, this is a bit surprising because if you look at the actual pictures, all of them are showing region of descent, which I discussed 2 weeks ago. Let me see it is there here or not. This is a picture I showed last week. This is what it is still continuing to be shown by most models, that over the next few weeks, this brown thing, which is region of descent, large scale it is, not just local. And on 18 July, which is 1 week back, it showed that it didn't penetrate in India, but in the next forecast, this brown thing entered India. Okay, so the next 1 week, if Indian monsoon rainfall is going to be all India normal, it will be mainly because you will find more rain in South India and rain along the foothills. And in between, there will be no rain. That is the forecast. Now, this has caused a lot of debate among people who know a lot about this. See, normally when the rainfall hits the foothills of the Himalayas, you call it a break. What happens is when there is no rain in the heart of the Indian region, the rainfall still occurs close to the mountains as long as there is wind blowing towards the mountain. So that's called the break condition. But I talked to the experts on this. They say what's happening in the coming week is not really a break situation. It's rather unusual that it's going to rain close to the Himalayan foothills and in South India, but not in between. Okay. Now that I'll show you by, I think it is there. I'll again show it to you. Yeah, this is the picture of forecast based on 23rd July for the period 24th July to 7th August, 14-day period. And it's anomaly. Okay? Anomaly I like because the model biases are removed. Every model has a bias. So there's a two, left is the GFS ensemble, right is the ECMWF.
both are very similar. Okay. So I believe this is going to come true. You can see a lot of rain, green things along the foothills and green thing near South India, low rain over the Western Ghats and low rain in Central India. So this is very unusual. So let us see whether the forecast made by both GFS and EWF come true the next 1 week. That we will follow next week. Continuing my point, now I want to show you the forecast made for the different subdivisions of India, divided into 4 parts, based on 14 July and 21st July. So you must remember, 14 July forecast goes for 15, 22nd, 29, and so on. The next one, the most recent one available, the one will be given today evening. So based on 21st, it is saying that in this week, which we are in, it will be 3% above normal, and that will be partly right. Okay, but look at the next week. Next week it is minus 6.73. So it is predicting not a break, but a weakening of the monsoon in the next 1 week and the week after. So it looks like in the period from the end of July to 4th August and 5th 11th, Indian monsoon will be weaker than normal by around 6 to 8%. Okay, but if the later in the week, that is the 4th week, it will recover back to normal. That's what it's saying. And you can see a slight difference between the forecast of 14 and 21st. 14 July said that for the period 22nd, 28th, that is this week, it will be 8% above normal, but the next week forecast brought it down to 3%. Okay, and that's more closer to what is observed. But the forecast for 29th July, 4th August is very similar, interestingly, 6.6 to 6.73. But if you look at the next forecast, so minus 7.2 and minus 9.4, so it is showing a more weaker monsoon. Huh? Yeah. 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 Let me go back. You talk again here, you can talk a little more loudly. Or you come to the friend. Be a friend bencher. Yeah. 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 Right. Yeah, I'll tell you, my gut feeling, I have not verified this with people in Delhi and Pune. These models are doing well in the first 2 weeks, mainly because of data assimilation. Models errors have not been reduced. Okay, those problems are still there in every model, not this model, every model. So all the models are doing better because they assimilate a huge amount of satellite data. Okay, you talk to people in NCR earlier, whatever data satellite gives, they put it in. Okay, so that means water vapor is going in. So my gut view is that model's accuracy is completely dependent upon how correctly you specify the water vapor for today. Because the right water vapor, the model goes the right way. So that's why the first week forecast is always good. Doesn't matter what condition it is. So I think that's what's happening. And so I think as the monsoon weakens and water vapor starts declining, immediately you see an impact on that in the next week's forecast. But somebody has verified this. This is somebody has to do with and without data assimilation and show how much the difference is. But people in Delhi are too busy. I think they don't have time for it. But somebody has to do it. If somebody can get the initial condition with and without data assimilation, it will be worthwhile too. But there is a paper I recommend all of you, published by Rajgopal, I think from NCWF, where they showed the impact of megatropics, because that interested me because I was involved. So megatropics gave water vapor, and they showed that keeping that and not keeping that had a big impact on the forecast. So clearly water vapor is the key parameter to assimilate. Because remember that we don't have very high quality wind data from satellites. We don't have it. Even rainfall data from satellite has its own problem. But water vapor is a very good parameter measured by at least 10 satellites. And they put all of them in. So I think that is the main advantage. Let's look at the state of 3.4. It is minus 0.4 now. It is becoming more La Nina-like. And what I want you to remind you is last time I didn't do it. This time I put the boundary of 3.4. Look at it. Most of it is very, very cold, -1 and above. A small portion, because of those waves, is positive. Very small portion on the east corner. And that is what's making it a little less. But majority of the 3.4 region is highly negative. And in my view, it is the region close to the dateline which has more influence on India than the region far away. So, so for our purposes, we are having a fairly strong La Nina. I think there's a slight region onto the Nino 1 and Nino 2, which are close to 0, but really that doesn't have impact on the Indian monsoon. I found out that if you explore the IMD website sufficiently, you'll find all kinds of forecasts. They do forecast, 3.4. I didn't know that. Okay. So this is a forecast they made in May. Okay. May initial condition, they forecast for July -0.5. It is -0.4. Pretty good. I would say it's a good forecast. Then let's look at IOD. They forecast IOD in July to be -0.5. Based on May, -1 now. And you saw last time it suddenly plunged. We don't know what the reason is. And 1 plus 2, right? The coast of Peru is close to 0. Okay, because there's all those waves which are bringing in warm water from equatorial region. So all these things is being forecast quite accurately by most coupled models. Now this I already discussed. This is the week 2. Okay. And you can see this is what I think is going to happen in the next few days. You'll find very large scale, all the way from equatorial, all the way to India. The northwest southeast orientation is going to come. But interestingly, I would expect it to have a huge impact on Indian monsoon. But according to the model, because of the rainfall for South India and the foothills, is going to get averaged out. Although Arindam doesn't believe in it, but let's see. Arindam was expecting a much bigger break, but so far it has not happened, right? Huh? Yeah, but all India monsoon rainfall is not declining as much as we expected. That is the surprising part. Yeah. But you are saying that one of the interesting, water vapor is above normal, right? Yeah, see, that's the point which, if you look at only the circulation parameters for break condition, that may be misleading. If the water vapor is anyway high, in spite of adverse circulation parameters, rainfall may still occur, right? So that is the problem this year. Water vapor is above normal. And that can be seen, I think, in the, let me see whether I have it. Yeah, I'm not showing India here. The Bay of Bengal is very warm. Arabian Sea, part of it is warm, part of it is cold. Okay, I just want to mention this new paper that come out for those who are interested. You remember this year, there's a lot of heat wave in Europe. Last week, we discussed the one in Great Britain. Now next is coming in other countries. So there's a very nice paper saying that there are double jets in mid-latitude now, not single jet. Okay, and that double jet is causing this heat wave. So I want all of you to read it. It's I think easily available, this paper. So they are arguing that Europe has more double jets than North America, and hence has more heat waves. And this is what they say is a new trend. Okay, it's a very interesting paper, and I'm curious to know whether this double jet, this is for Venu, has impact on the connection between mid-latitude and India. That's a question we have to ask, right? Huh? I can't hear you. Yeah. Oh. Okay. Yeah. So for instance, 10, 2010, yeah. Yeah. Right. Yeah. Yeah, I want to tell you all this complicated now. In the last 3 or 4 years, I've seen so many review papers on ENSO, okay? And here is one of them in which they have shown all kinds of complicated interaction between Pacific Ocean, Indian Ocean, Atlantic Ocean, okay? Huge links are being shown all over. So there's not a simple just ENSO monsoon connection. You have to worry about what happens in Atlantic, what happens in Indian Ocean, and they're all linked to each other. So there is no simple result that one can talk about. But you can read this paper, they're interesting. Okay, so I conclude by saying that if the rainfall in June, July is going to exceed 450, definitely it's exceed 450, we are going to have rainfall anywhere around 800, 900. Closer to 900 is what I think you will see. Okay, I think I will stop here. And yeah, this is what I showed earlier. Actually, there's a paper, another paper by Wallace in which the same pattern is shown between the two kinds of what do you call pattern of the east-west and the north-south. Okay, so next week is Shikhar Srivastava. Yeah, so we'll meet next week at a normal time, 3:30 p.m. Thank you. Anybody has a question? Anybody from the